Download this code from codegive.com, link in the description below. Troubleshooting and handling Azure Blob storage timeout errors during artifact uploads. Azure Blob Storage is a highly scalable and reliable object storage service, but you might encounter timeout errors during artifact uploads. These errors can disrupt your pipelines, deployments, and workflows. This detailed tutorial will guide you through understanding timeout errors, identifying the root causes, and implementing effective solutions with code examples. Understanding timeout errors. Timeout errors in the context of Azure Blob storage uploads usually manifest as HTTP 408, request timeout, 500, internal server error, with underlying timeout details, or client-side exceptions like system.timeoutexception. They indicate that a network connection or a storage operation took longer than a predefined threshold to complete. Why timeout errors occur? Several factors can contribute to timeout errors. 1. Large file size * uploading very large artifacts, especially over a network with limited bandwidth, increases the likelihood of timeouts. The larger the file, the longer it takes to transmit, and the higher the chance of exceeding the allowed time. 2. Network latency and instability * high network latency, the time it takes for data to travel between your client and Azure storage, can significantly impact upload times. Unstable network connections, characterized by packet loss or intermittent outages, can also cause uploads to fail due to timeouts. This is particularly relevant when the client is located far from the Azure region. 3. Client-side configuration * incorrect or insufficient client-side configuration, such as inadequate timeout settings in the code or connection pooling issues, can lead to premature connection termination and timeout errors. 4. Azure storage service issues * although rare, temporary issues within the Azure storage service itself can lead to increased latency or intermittent failures, resulting in timeouts. Keep an eye on the Azure status page, status.azure.com, for any reported incidents. 5. Proxy servers and firewalls * proxy servers or firewalls can introduce latency or interfere with the connection, leading to timeout errors. Ensure that your network configuration allows for proper communication with Azure Blob storage endpoints. Specifically, you need to allow outbound traffic to port 443, HTTPS, for the storage account endpoints. 6. Incorrect storage account configuration * in rare instances, issues with the storage account itself might contribute. Consider factors like the storage account type, example standard versus premium, and replication configuration. Premium storage generally offers lower latency and might be beneficial for critical upload operations. 7. Throttling * Azure Blob storage has limits on the number of requests that can be processed within a specific time period. If you are uploading many files concurrently, you might be hitting throttling limits which can manifest as timeout-like errors. Identifying the root cause. Before implementing solutions, it's crucial to pinpoint the specific reason for the timeouts. Consider these troubleshooting steps. 1. Monitor network conditions * use network diagnostic tools, example ping, traceroute, path ping, to assess network latency and packet loss between your client and the Azure Blob storage endpoint. Significant latency or packet loss suggests a network-related issue. 2. Examine logs * review logs from your application, Azure storage logs, if enabled, and any network infrastructure devices, example firewalls, proxy servers, for error messages or unusual activity. Storage logs can provide insights into the timing of requests and any service-side issues. Enable Azure storage logging through the Azure portal. 3. Test with small files * attempt to upload small files. If small files upload successfully, the problem is likely related to the size of the artifacts. If even small files fail, suspect network issues or incorrect client configuration. 4. Isolate the client *. Try uploading from a different client machine or network. This helps determine if the problem is specific to your current environment or a more widespread issue. 5. Check Azure status *. Verify the Azure status page for any reported service incidents that might be affecting Azure storage. 6. Monitor storage account metrics *. Use Azure Monitor to observe key storage account metrics like E2E latency, success E2E latency, throttling error, and network error. These metrics can reveal performance bottlenecks or service issues. Solutions and code examples. Once you've identified the likely cause, apply these solutions. 1. Increase timeout values *. Adjust timeout settings in your code to provide more time for uploads to complete. The Azure Storage SDKs expose settings for configuring timeouts. See example, using azure.storage.blobs. Explanation ***. Storage transfer options. This class allows fine-grained control over the transfer process. Initial transfer size specifies the initial size of each transfer. Adjusting this can improve performance. Default is 256 KB. Maximum concurrency sets the maximum number of concurrent transfers. Increasing this can speed up uploads, but it also consumes more network resources. Adjust based on your network bandwidth. Default is 1. Experiment with values like 4, 8, or 16. Maximum transfer size, the maximum length of a transfer in bytes. The default maximum transfer size is 4 MB, 4 1024 1024 bytes. This is crucial for large files. Error handling, the try-catch block handles potential exceptions during the upload process. Always include proper error handling to gracefully handle failures and log relevant information. Python example, using Azure Storage Blob. Explanation ***. Max concurrency, this parameter controls the number of concurrent connections used for the upload. Increasing it can speed up the process, especially for large files. Experiment with values based on your available bandwidth. To implement chunking, blobs divide large files into smaller chunks, blocks, and upload them individually. This approach allows for retries on individual failed blocks, improving resilience. Azure SDKs usually handle this automatically. See example, using azure.storage.blobs, already using this implicitly in the previous example. The blob client.upload async method in the C example automatically handles chunking, blob creation, for files larger than the threshold specified by maximum transfer size in the storage transfer options. You don't need to explicitly manage blocks. Python example, using Azure Storage Blob, also handled implicitly. The blob_client.upload_blob method in the Python example automatically handles chunking, blob creation, when blob_type equals blob is specified. You don't need to manually manage block IDs. 3. Use managed identities, recommended for Azure environments instead of connection strings. Use managed identities for Azure resources to authenticate to Azure storage. This eliminates the need to store secrets in your code or configuration files, enhancing security. See example, using azure.identity. Explanation ***. Default Azure credential, this credential automatically attempts to authenticate using various managed identity providers available in the Azure environment. Example, system assigned managed identity, user assigned managed identity. Make sure the managed identity has the storage blob data contributor role assigned on the storage account. *blob endpoint, replace your storage account name with the name of your storage account. Python example, using Azure Identity. Important * for managed identity authentication to work, your application must be running in an Azure environment, example Azure VM, Azure App Service, Azure Functions, that has managed identity enabled and configured correctly. The managed identity needs the appropriate RBAC role, example storage blob data contributor, assigned to it on the storage account. 4. Implement retries with exponential backoff * use retry policies to automatically retry failed uploads, especially when dealing with intermittent network issues. Exponential backoff gradually increases the delay between retries, giving the network time to recover. See example, using Azure SDK retry policies. Explanation **** retry options. This class allows configuring retry behavior. **mode, choose retry mode. Exponential for exponential backoff. **max retries, the maximum number of retry attempts. *delay, the initial delay before the first retry. *max delay, the maximum delay between retries. *blob client options, pass the retry options to the blob client options. The blob client is then created using the updated options, ensuring all operations on that client will use the specified retry policy. Important, the true parameter in blob client. Upload async, upload file stream, true, overwrites the blob, otherwise you will encounter a blob already exists error on retries. Python example, using retry decorator from the Tenacity library. Explanation ***. Tenacity library. The Tenacity library provides a flexible way to implement retry policies in Python. Install it using pip install tenacity. *@* retry decorator. This decorator automatically retries the decorated function according to the specified retry policy. *stop, defines when to stop retrying. Stop _after _attempt, 5, stops after 5 attempts. *wait, defines how long to wait between retries. Wait _exponential, implements exponential backoff. *retry, defines which exceptions to retry on. Include common network-related exceptions. *raise inside except block, re-raising the exception allows the retry decorator to catch it and trigger the retry logic. Exception handling. Carefully consider which exceptions to retry on. Retrying on all exceptions might not be appropriate. 5. Optimize network configuration. Proximity to Azure region. Ensure that your client is located in or near the same Azure region as your storage account. This reduces network latency. Accelerated networking. If your client is an Azure VM, enable accelerated networking to improve network performance. Avoid network bottlenecks. Ensure that your network infrastructure is not experiencing bottlenecks that could limit upload speeds. Use Azure Express Route. For dedicated, high bandwidth connectivity, consider using Azure Express Route. 6. Consider Azure Data Box. For extremely large data sets, terabytes or petabytes, or scenarios where network connectivity is limited, consider using Azure Data Box to physically ship the data to Microsoft for uploading to Azure storage. 7. Monitor and adjust concurrency. Carefully monitor the performance of your upload operations. If you see throttling errors, reduce the concurrency level. If you have ample bandwidth, you might be able to increase concurrency to speed up uploads. 8. Enable Azure Storage Analytics Logging and Metrics. Azure Storage Analytics provides detailed logs and metrics for your storage account. Enable these features to gain insights into the performance and availability of your storage operations. Analyze the logs to identify potential issues, such as high latency or throttling errors. 9. Utilize Azure CDN, Content Delivery Network. While CDN primarily focuses on content delivery, consider using it if your upload process involves multiple clients in different geographic locations frequently uploading the same artifacts. The CDN can cache the artifacts closer to the clients, potentially reducing upload times. Key considerations and best practices. Security. Use secure authentication methods like managed identities whenever possible. Avoid storing connection strings directly in your code. Error handling. Implement robust error handling and logging to capture and diagnose timeout errors. Testing. Thoroughly test your upload process with large files and under varying network conditions to identify potential issues. Monitoring. Continuously monitor the performance of your storage operations and adjust your configuration as needed. Azure SDK updates. Keep your Azure SDKs up to date to benefit from the latest performance improvements and bug fixes. Immutability. Consider using immutable storage, using legal hold or time-based retention policies, for archival data to prevent accidental modifications or deletions. By understanding the causes of Azure Blob storage timeout errors and implementing the appropriate solutions, you can create robust and reliable artifact upload workflows. Remember to carefully analyze your specific environment and requirements to choose the best approach for your application. Good luck.